Okay, so hello and welcome back to another Unity tutorial. In this one I'm going to be doing another video in the creating abilities and characters from popular game series. I mean, that's not the official title of the series, but we'll go with it. So in this one, because quite a lot of people showed interest in the last video, and I feel like people definitely will want the series to continue. It got quite a lot of views quite quickly, so, well, at least for my standards. So what I'm going to do is, this video isn't really going to be about Genji doing part 2, it's more of, I'm going to title it that because it is part 2 in the series, but the point in this video is to recreate the movement system so that it's less glitchy and just better to expand upon. We're not going to be using transform.translate to move and rigid body to add force. We're going to be using our own character controller, and we'll code the class so that we can handle force in our own way, which will help when we do jumping and when we do wall climbing. So this video will be implementing the new movement system and then changing the Genji code from the last video to work with the new system. And then next video will be wall climb and projectiles. I know I said it would be this one, but the problem is if we try and do wall climb now, it'll be awful, because I'll show you why in a second. And then this itself will take, about 15 to 20 minutes to set up while I'm explaining it. So I feel like it does deserve its own video. So I'll do the other one tomorrow. Once we set this up, I'll do the double jump and projectiles tomorrow. So I hope you're okay with that. So let's get into this video. Before we get into the video though, I want to thank my patrons. Thanks to Michael, Paul Robinson, Forborm and Norwegian Viking for their donations on Patreon this month. If anyone else is able to help out and like to support the community, then it would be greatly appreciated. Link is in the description below. Apart from that, let's get into it. So some changes we gotta do. We gotta go to Genji and we gotta remove, actually no, we'll go to the player base prefab because that's where, it's inherited from. We're gonna remove the rigid body. No, we're not. We're gonna remove the capsule collider, and then we're gonna go into the movement controller and we're gonna remove the thing that tells us we have to use a rigid body. We're gonna tell it we have to use a character controller because that's our new way of doing things. We're just gonna give that a second to compile, and then we can actually remove the rigid body and add a character controller. So if you've never used a character controller, it's a built-in thing which is very handy for doing characters, obviously. It already has some automatic things, such as you see, the step offset, which is quite handy, which allows the character to go up steps of a certain height that you define, or like go up ramps of a certain angle that you define. You could code this yourself. I mean, anything you can code yourself, but the point is it's already built in and it's very useful, and it's not a very obtrusive thing where like you have to use stuff its way. It has a function called charactercontroller.move where you pass in where you want it to move to, and it handles collision checking for you, and it's just very handy for doing smooth movement with capsule shaped characters. Obviously by that I still mean humanoid people are quite capsule shaped as capsules go. So what we need to do is, well, we'll add this, and it actually has its own capsule collider as part of it, so you don't need to worry about falling through the ground or anything. It's kind of done with it. So what we need to do is we need to go to our movement script, and we need to do quite a few changes because we're going to change the entire way it works. So we still need move speed and jump force, but we also need we're going to make these protected so we can tweak them if we need to in the children. We're going to make mass, which will default to 1, I don't know, and because we're handling our own physics inside here, we're going to need our own mass. I'm going to set the jump force to be like the default of, I think it's 4 we were using, and the move speed to be 5 maybe. And we also need I'm actually going to use the shortcut Control D to duplicate a line. Oh, that didn't help. And we'll call this damping, so it's like our own air resistance, and I'll set that to 5 or something. And that's because we're going to be handling external forces ourselves, like when we do jumping or when we get hit by a knockback, we're going to be handling that here. So we need to have our own air resistance, which normally is part of the rigid body, but we're not having a rigid body, so just like I said, we're going to get rid of rigid body, and we're going to store a character controller, not a char. Character controller. Character controller is the name. And then we're going to store some private variables. So we're going to have a bool. Actually, we don't need to know if we're grounded because the character controller does that now. So we're going to need a float velocity y, which is going to store our velocity y. Usually, well, it's going to be dependent on gravity. If we have any other velocity y changes, then it'll be like an external force, and we're going to store that in a private vector-free current impact, which is going to be handled every frame to be... Actually, let's make these protected, because we are inheriting from this class a lot when we make other characters, so we might want to tweak these or know about them at least. In the awake, we don't care about a rigid body. or the distance to feet anymore, because the character controller handles ground checks for us. So we're going to do character controller is equal to get component character controller. So now we have reference to our character controller. We still want to move and jump every frame, but we want to do it differently. So I will get rid of that code, because we still need to check space. And we don't need the grounded function anymore, so we can get rid of that. Now in the move, what do we want to do? Well, we want to take in our input as we were, but let's make this a vector 3. Make it equal to a new vector 3. And right in the middle of here, we're going to add in another comma for another parameter, and we're just going to set it to 0. Because we could have done that originally. That just means that rather than passing in 0 here, we do it here. It just is nicer, and we're getting rid of these two because we don't want that. So we've got our movement input like we used to, but we're going to treat it differently. So the first thing we're going to do is we're going to make sure that if we're on the ground, we don't try going through the ground, because we don't have rigid body handling gravity with our collider and everything. What we need to do ourselves is we need to basically say, while we're not on the ground, go down, or when we are on the ground, don't go down. So we're going to say if we're grounded, so if character controller dot grounded, dot is grounded, if I can spell grounded. And so we need to make sure we're on the ground and our velocity y is less than 0. And the reason why I'm checking if it's less than 0 is because gravity in terms of a game engine is negative, because you go down. Obviously, when you do physics and maths, you would say gravity is just a number, right? You'd say it's 9 newtons or 9.8 newtons per second, whatever. Well, not newtons per second, newtons, and then that translates into a velocity. So what we need to do is we need to set our velocity, as I was saying, to 0 in this case. And that's because when we're on the ground, if we didn't do this, what would happen is it would keep building up a velocity, getting, well, smaller and smaller, so it'd be going negative. It would be getting bigger in the negatives, if you know what I mean. It would be getting like minus 1,000, minus 1,000,000, whatever. And as soon as we step over the edge and we're meant to fall, that's when we want our velocity to start going negative, but it would already be a really big number in negatives, and you would just instantly plummet down really quickly. So that stops that happening. So now we want to actually handle the gravity. So velocity y, we're going to add gravity. Oh wait, I never actually defined that at the top. All right, one sec. Gravity multiplied by time.delta time. Forgot to do that. So what we need to do is at the top near our protecteds, we'll make a we make it private. We don't need to access it anywhere else. Private read-only float gravity. I'll explain the read-only bit in a second. We're going to set that equal to physics.gravity.y. So gravity, in terms of Unity, is just a global force that applies to everything. In real life, you think gravity, acts downwards. You can have gravity in Unity and game engines that act in any direction. So you could have going up to the right if you want. I don't know. It's up to you. Normally, you'll just have it be 0 in the x, something in the y, and 0 in the z. So we're going to store the y component, which is just, normal gravity, as you would say. And we're going to store that in here because we're handling physics ourselves. But I'm going to cache it at the start, and that's just so that gravity doesn't change. So there's no need to access it every single frame. We might as well just store it. It has like a slight performance increase. It's not like drastic, I don't think. Maybe it is, but it's still just better to do this. And we're making it read-only because, well, normally you'd make anything like this a constant, but the problem about constants, I think it'll tell us in a second, you can't, well, as far as it's aware, gravity could change, because this is a getter to a vector free, and like through the physics class. So if that changed, it doesn't like that basically. Read-only means you can't change it, but it can change. It's this very, very weird way of explaining it. Think about it this way, you can't set constants as a property at the start, a variable at the start, if the thing you're getting it from can change. So like obviously I could make a constant float and just set it to, minus 9.81 f. And that would be fine, but because that can never change, that is just a value. But because this is like a variable thing, it doesn't know what that is before it compiles. For it to be constant, it needs to know the value at compile time, whereas read-only doesn't, so that's handy. And then we're going to, handle that here. We're going to times that by time.delta time, so it does it correctly per frame rather than, per second rather than every single frame taking off gravity. Well, it adds gravity, but gravity is negative, so it's adding a negative, which is just subtracting. Velocity, vector free, sorry, not velocity. This vector free called velocity, we'll call it velocity, is our movement input, which we've already got at the top line, multiplied by our movement speed. And we're going to add that to up multiplied by our velocity y. And that's because, well, velocity y is a float, but we need it in a vector form, and it's only in the upwards direction, so that gives us a 0 velocity y0 vector, because it's multiplying it by 0, 1, 0. Now that we've done that, we need to say if, well, we don't need to do this bit, but I want to do this bit, if the magnitude of our current impact is greater than, like, 0.2, we want to set our velocity, no, not set it, sorry, we want to add our current impact to it. Current impact is any external force, so like, let's say we get hit by a knockback and from like multiple places, or we've got like some heavy winds and we've got more forces on us. Basically what this does is, when we add this in this line, it's meaning like we're taking it into account. We could have some external force on us and store it in a vector free, but not actually, you know, do anything about it. We could just store it. So we're saying we're only going to take it into account when it's greater than 0.2 in magnitude, and that's just so that when we decrease it, it'll never actually reach 0. It'll just get so close to 0 that it's basically negligible. Because when you do lerping, you get close, but you never get all the way. I mean, you can technically get all the way. So what this stops it doing is, if we're like standing still and we had force acting on us, but we don't anymore, we might still be sliding like ever so slightly, like very, very, very slightly, but it can, you know, just look a bit weird if you're standing still but your camera's moving slightly. So this just only means we're going to physically move when we've got a magnitude greater than 0.2. It's not noticeable anyway, it's fine. You can try with that line out and you might see what I mean, and if you do see what I mean, then add it back in, it's up to you, but I'd recommend it anyway. And now character control has a move function which takes in the motion, the vector of where it wants to move. So we're going to take in the velocity, which we've already calculated, and multiply it by time.delta time, so it's correct. And then after this, we want to say if the movement input, actually sorry, this is not, we don't need this. We need to just end off by saying our current impact, which we still haven't set anywhere, but we're still doing stuff with it. We're going to lerp it. So I've covered lerping before. Hopefully you know what it is. You pass in two numbers, or two vectors in this case because you're using a vector version, and t, which is a kind of like how far between the two numbers we're going to go. So if we take our current impact and vector 3.0, that means we're going to go from our current impact to 0, 0, 0. So effectively we're reducing the external forces per second, just like air resistance reduces it per second. And the amount is t, so we want to do it by damping multiplied by time.delta time. If we just did it by damping, then what would happen is it would slow down faster if you had a higher frame rate and slower if you had a lower frame rate. It would be a bit silly. So this time.delta time helps a lot when you are making things frame independent. You don't care about the frame rate, so time.delta time. And that's the movement. Now we might end up splitting that into functions, but for now that's good enough and that'll work. So what we need to do is we need to go above the jump, I guess. I mean, I might, if these are the protected methods, I might go and put the public ones somewhere else. But I feel like jump, I'll go put it at the bottom. We're going to have a public void add force, which takes in a direction, which is a vector 3, and a magnitude, which is a float. And we're going to say normalize it. Whoops. Normalize. And if the y is less than 0, so if we've got a force adding to us, but the y is negative, meaning we're going to go down into the ground, we want to, well, I mean, this is up to you. You know, I might just ignore this. We don't need this really. We'll just say current impact plus equals direction multiplied by magnitude over mass. And to be honest, we could even make this a one-liner. Just get rid of that and do direction dot normalized. There we go. So we're going to normalize the direction, so it's regardless of how big the vector is, it's only caring about the direction, which is the point. Then we're going to multiply it by the magnitude over our mass. So the bigger our mass is, the smaller the impact's going to be, which makes more sense because that's how, you know, that's how it works. If you are more massive, then, well, massive in the sense of you have more mass, then when something hits you, it needs to have more force to move you the same. It's just basic physics. And now, what we can do is when we jump, we can actually add force. Well, actually, no, sorry, we need to check it from the ground. So if grounded, if character controller dot is grounded, sorry, we want to add a force, and we want to add it in what direction? Upwards, vector 3 dot up. And how much? Jump force, which is what we've already declared. So this script is done for now. We're going to get some errors in the Genji controller probably, if we let it compile. Yep, 3 errors, okay, 4 errors. So grounded is going to be character controller dot grounded now. And rb.velocity equals is going to be, I notice how we're setting the velocity there, so that kind of means that we are, see, the problem with this, that how I did it was, that's regardless of how far down we're going. Yeah, I feel like that still makes sense though. When we jump on Genji, we want to get rid of all our velocities and then set it equal to upwards on our jump force. Yeah, the only problem with this is if you're being knocked back and you jump, you still want to carry on getting knocked back, you just want the Y to be overridden. So we could like work around this, and we could make a function in the movement controller, a like protected void reset impact, and that just says current impact is equal to vector 3 dot 0. But then maybe we only want to clear it in like one direction, so we want to say protected void reset impact, and we'll take in a see, we could make reset impact X or Y. I mean, you know what, for now I'm just going to say this. Current impact dot Y is equal to 0. That's just a simple fix for now. I can sort that out later. So we want to say reset impact Y, and then we want to say add force in the upwards direction, and our jump force is the amount. And then where we said is grounded, we want to say character controller dot is grounded. Don't want the function brackets. And down here we want to do the same thing as here, so reset the Y and do that. Yeah, I might come back in the sub at some point, but for now that works. Genji should be fixed. Nice. We'll go to our Genji and see if everything's okay on him. So character controller, Genji movement, Genji dash. The dash needs to be fixed, I think, because we don't want a rigid body here. We want a character controller. No, we don't. Sorry, we want a player movement controller. Player movement controller, because we are handling it through our own script. So player movement controller, and we'll just say player movement controller is equal to get component player movement controller. And we could do the good old making sure that we have a player movement controller for the dash to work, which makes sense because we do need one. And then down here, rather than adding force, we want to just say character controller, sorry, player movement controller dot add force. The direction is that direction, comma, the force is dash force. Stop, and we can get rid of that line now. And when we do this velocity equals 0, we just say player movement controller dot reset. Yep, that's why I need to make it a public function. Reset impact public, and that's what make that one public if we're going to be calling it externally at some point, maybe. Reset impact. Cool. Now we should get no compile errors. We should be able to look on Genji and see we have some like values, the jump force, speed, mass, damping. I don't know, I'm just going to tweak some numbers. Let's see how it all works. Let's press play. So does everything work? Well, I can jump, I can do double jump, I can Oh, okay, yeah, one thing I've got to fix for definite. When I move, it's moving in the world direction, not my direction. I know how to fix this, so don't worry, I'll do that in a second. And when we dash, the dash works still. So that's cool. Let's just go fix the movement. So if we go back to the main movement script, the base one, we want to say, when we've got the movement input here, I can't click, we want to change it to be relative to the player's direction rather than the world direction. So we can say movement input, movement input is equal to transform, which is the transform of the player, dot transform direction, and we pass in movement input. And what it's going to do is it's going to make it so we move. Oh, I missed out a T. It's making it so that the movement we are giving does not make us move, in the X in the world. It'll make us move in the player's X direction. So now I should be able to press forwards and rotate the camera and go wherever I'm looking, which does work. So if I walk into this object now, you'll notice I don't glitch like I used to. It used to just like spaz out and go inside the thing and whatever. But now I can walk up to it and I can jump and double jump. So normally I can't get on this object, for example, but I can double jump on it and jump, 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 dash. There we go. And obviously if I fall off it and press jump, then I just get one jump. So one thing though I've just realized, when I do this reset impact, that's fine. But, the problem is, when I want to jump, I want to set the entire thing back to 0. So as well as resetting the impact to 0, kind of want to reset it all to 0. So the current impact and velocity y is what I want to reset to 0. So velocity y is equal to 0. And then on here it is as well, obviously. So current impact dot y. Yeah, because that only affects the y. That's fine. Okay. As I said, those functions, they were just something I made now. There's like a quick fix. Sometimes you do just want to make quick fixes, but jump, 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 dash, jump, jump, dash. I'm on the box, and now if I go off it and go jump, it goes up the normal amount, right? So I can go jump, dash. Okay, cool. So that's it for this video. Also, yeah, if you try dashing into the ground, you just kind of go across the ground a bit. You don't stupidly glitch through the ground. And if you do it into objects, you stop at the object rather than glitching in them. So that's cool. It works really well. It feels a lot smoother than it did. I hope you enjoyed this video. The character's just much better in general now. So that lets us go on to the next video where we'll be doing the wall climbing, and hopefully it won't look stupid this time. So we'll add wall climbing with limited duration of wall climb. We'll be using ray casting to check if the thing in front of us, if there's something in front of us to climb up, and whether it is climbable. We'll tag it with climbable or make some way to tag it. We could just use the built-in tag system, but it isn't great because you can only have one tag on things. Another way people used to tag things is just by making an empty script, which sometimes is probably what you want to do. Make a script called climbable and just drag it onto anything that's climbable. It's a solution that works. So we will be doing that next video, and hopefully you'll be able to make this guy like 15 and go and put him there to 7.5. Maybe we'll be able to get up him next video. So that's the goal. I haven't got cooldowns yet, so technically you could just dash, dash, dash up there, but you get the point. Well, we want to walk up, hold spacebar and go up it. So I hope you stay around for tomorrow's video. I hope you like this video. It was a long one, but it had to be done. So yeah, I need to stop rambling now, sorry. So if you haven't already, leave a like and subscribe, it'd mean a lot. Join our Discord server, the link is in the description below. But apart from that, thanks for watching, and goodbye.